Welcome to the Scicloj community, and I'm John Stevenson. I have the pleasure of moderating this discussion. And this community obviously discusses all things data science and data engineering, demonstrating how we use Clojure to build tools and applications that make data science more accessible, more fun, more interesting. And this week we're going to continue our journey into data visualization and literate programming. And we have Jon Anthony with us this time around. And John's created, I'm probably going to get the names of these projects wrong, but Hanami for interactive arts and chart visualizations with Clojure script. And that's built on Vega and Vega Light specifications. And as I mentioned earlier, we're not really going to go into Vega and Vega Light in any detail. We did that last time in the Oz video, which is there's also a link there in the chat about that as well. So if you want to know more about Vega and Vega Light, then please take a look at the previous video. And we also assume you've got some basic Clojure language experience as well, so you know what map and reduce and immutable data structures are as well. And John's also going to talk about Saite, which is about exploratory graphics and visualization systems, and that's built on top of Hanami as well. And so I think you can find John on, is it JSA-Ariel? I think that's his GitHub account. And we'll add links to the projects in all the show notes as well. Feel free to ask questions or put them in the chat, and I'll keep an eye on them and make sure we get them answered. And yeah, just make sure that if your microphone is on mute, if you're not speaking, that would be great. And so we minimize any background noise as well. Okay, without further ado, let's hand over to Jon. Thank you very much.
Okay, so as I was mentioning to Stephen before everybody joined, and then this thing went off the rails. This is going to be a bit of a guinea pig thing in a way, because I'm going to give the presentation using Saite. So right now, if you're looking at this thing, this is basically a Saite document. You got a little title, Scicloj, you have a bunch of tabs. And these tabs are sort of like what normally would be like slides or something like that, except that any of them will have interactive capabilities. So the basic, what I'm going to try and do here is give an overview of both Hanami and Saite, so kind of a short intro on Hanami and a bit about the templates, tab capabilities, picture frames, what those things are. Mainly because all of that ends up being a big piece of all of this interactive visualization stuff that actually is now in the current version of Saite. Okay, and then Saite is a bit of a history about how this thing came about, and some talk about the editor, its capabilities, and the current state of the thing, and then how to publish stuff, formats, and then a kind of a future roadmap, possibilities of things that that are left to do, or would maybe be nice to have, and things like that. Okay, so we just move around these tabs. So in a way, as we're going through this presentation, you're going to be seeing some of the capabilities of this thing. Okay, so if we just flip over here, now we have, okay, so now Hanami is really is a library with some framework aspects to it. It's basically enables the construction of visualization applications based on Vega and Vega Light. It's kind of analogous to Shiny and Dash. It's a bit lower level than those things, so it's a bit more programmer oriented. It's a server and a client, or it could be client only. So you can just have client only applications. It has this template system, which is really, these templates are basically a way to abstract visualizations. So I think Christopher mentioned last time this thing about Altair as a an abstraction over Vega Light for Python that the Interactive Data Lab people themselves actually support. And it kind of gives you a little more leverage in terms of easier, less wordy, however you want to say that, and ability to do Vega Light visualizations. It doesn't have the ability to do Vega, but it is this abstraction over Vega Light. And these templates are really an abstraction over both of them because they're just data, and Vega and Vega Light are both just data. So there's a recursive transformer that's part of this as well. And basically you take a template, which is composed, is just a map, really, mostly a map. There are vectors and things like that in it, but in large measure, it's mostly a map. And these things called substitution keys, which are the values of the keys in these maps. And then the transformer transforms those substitution keys through a recursive substitution. And at the very end, you end up with a Vega Light specification. There's a default set of templates. These things are pretty general, very general purpose kind of things that you can then build other templates with. There's also pieces of things in there. You don't have to have complete templates to be transformable. They can be fragments and things like that that can be then built into a hierarchically built up into more complete specifications. Yeah. Now the other thing is, and there's a default set of substitution keys, and there's and that's in this area Hanami common, and this general purpose transformer called XForm that lives in the common namespace as well. And the thing about it is all of this stuff is completely changeable. I mean, if you don't like, if somebody was mentioning they don't like the uppercase substitution key naming convention that I have, there's no reason why I can't just change all of that to make it, you know, be whatever you want. If that seems to be more comfortable and convenient for you. And actually, when we get into the little a template intro overview, it's going to be interactive, and at the end of that, I'll actually even show an idea of how you can just take the current thing and automatically transform the keys however you want, and then transform all the templates to use your keys. So if you wanted to just change everything, you could. I actually think it's maybe worth adding some default out-of-the-box capability to do that for people. But I haven't done that yet, anyways. It also has a simple but really nice messaging system that it sits on top of in order to do the client-server part. It's something that actually I really have. It's something I like a lot, actually. And I've used it in many other things other than just Hanami and Saite. The other thing is that Hanami uses reagent, and it also incorporates recomp, which are these reactive components that are designed specifically for reagent and React, and which is completely flex enabled. So everything is a Flexbox, which is really nice, and it has all kinds of really nice components and stuff that you can then use to create all kinds of layouts and whatnot that have direct interactive capabilities. And then there's a kind of framework aspect of this thing, which is it provides the idea is like if you have a page, you're going to have some headers and things like that. So it has a default header support. It incorporates this tab system, which is kind of a somewhat opinionated way to lay documents and pages out. It has this concept of picture frames, which is a way of encapsulating visualizations in all kinds of stuff, pickup, text, markdown, LaTeX, whatever. And it has this idea of session groups. This is really a publish subscribe thing. So if you had a Hanami application, you could have multiple people interacting with it at the same time, that kind of a thing. All right, so let's talk a bit more about the templates, because templates are kind of at the core of a lot of this stuff. And it's worth having kind of an idea of how these things work. Okay, and in the process of this, we'll see some more interactive capabilities here, and some of these new Saite operations and whatnot. So what we have here is a basically it's a REPL. It's a Clojure script, and you can it's built on top of CodeMirror, and in this particular case, it uses Emacs as its basic default setup. I've incorporated various CIDR key combinations to do code evaluation and stuff like that, because that's just what I'm kind of familiar with, and being able to move forward and backward and S expressions and that kind of stuff. So what we're going to do is use this capability to just do an interactive demonstration, kind of walkthrough of templates. And we'll build up a template as we go along and just sort of build one up. It's already there, but we'll see how it came about. So we have this transformation function, and the transformation function will actually take any kind of composite data structure, map, vectors, whatever, combinations of those, and they can be arbitrarily nested and arbitrarily deep. Another thing that's worth mentioning, I think, is that transformation system is built on top of Spectre. And I can't say enough about Spectre, because this thing probably wouldn't exist if it wasn't for that. It's really, really amazing how that thing supports this kind of serious transformation capability. All right, so this XForm thing takes a template, which can be any, like I said, any kind of data structure, and then it takes, there's a default set of substitution keys, and it can take any set of key value pairs here.
John, I'm sorry, could you zoom in a little bit?
I can
coding, I guess, if it is not a trouble for you.
I can attempt that. Let's see. Maybe if I use, that doesn't actually work.
Oh, maybe, so never mind.
Well, wait a minute. Let me see. Ah, there.
Oh, yeah. Wonderful.
That's Thanks. Better? Okay.
Yeah, so much.
Okay. Hopefully this is okay. Okay, so in this particular case here, we'll just evaluate that, and the results are over here in the output. And this thing, it happens to be the case that this capital X is one of these default substitution keys. And you can always check the value of that by getting the default for the thing. And it's an X, it's just the string X. And so when the transformation happens on this thing, it just changes and grabs the value of capital X and puts it in as the value of A. That's it. And here's another example where you can override those defaults. Here I just give capital X as one of the variadic arguments with foo, and then A gets a value of foo. And the same kind of stuff is going on for Y. Okay, so in this particular case, we're going to what we're going to do is say that X is this map, which has colon small y, colon capital Y. So the first thing that happens is A gets that map, and then that map gets recursively transformed, and capital Y is just the string Y. So that's how you end up with the final value there. There's that thing. If you don't have any substitution keys and you just have a key or value of some sort in the map, then that's literally the value. Okay, there's nothing there, so it just says, well, that is the value because there's no it's not a substitution key, and so there's nothing to transform. And we can see that there's nothing there, but we can always give it a value in this variadic form, and so you get that. Here's another example. What are we going to do here? Okay, so we get that. The interesting thing about this, so you put anything in here as far as that goes. This is a set, and so AB gets that. But now if we give it an empty set, any kind of an empty collection, if you look at any of those transformation rules in the Hanami documentation, one of those rules is that empty collections always get the special substitution value of remove, which is mapped to the Spectre none special value. And anytime you get a none special value in a transformation, it literally just removes the entire corresponding key and value. So in this particular case, we're going to say that foo is what will happen is A will get the value empty set, and then it notices that empty set is an empty collection, and so it gets the value remove, and then A itself gets removed, and this whole thing just goes into nothing. Let's take a look at some more complicated things. So a lot of the substitution keys, and we'll actually see a bunch of them down here, a lot of the substitution keys are mapped to none in the defaults. Because what you want to do is you just want to remove them unless you have some need for that particular field in the visualization. So come over here, you can see it's the same kind of thing going on. That's all being removed. So if we look at, this becomes really handy if we look at a few things here. You'll notice that all these data substitution keys are mapping to this none. There's this special thing, val data, which is a function. So you can have the substitution key's value can actually be a function. And what that does is during the transformation process, it's passed the current substitution map and the key. And then you can do whatever you want with it in there to return the value. So in this particular case, this val data thing is a function that what it does is it looks for both either data or F data. And data would be an inline thing, very just like the data in the data fields in Vega Light. But F data is something special in that what it will do is it'll go out and read files from the server in order to be able to get the set of data for the thing. So if we look at this, what's going on is that function notices that the data type is going to be an inline thing, and it just takes the direct value. So if this was a vector of x, y map, you would just get that. But you can also get it to be this kind of a thing here. Val data doesn't understand U data, so it just returns nothing for that. And that's why you get this nil over here. Now let's look at data options, which is a default thing that's used in a lot of the templates. Okay, and it's a way of being able to abstract over all these possible data types without having to think too much about them. And what we have is values goes to val data, URL, U data, name to end data. URL and name are both, these are Vega Light specific things. Name is a name data Vega channel. This URL is exactly what you think it is. The Vega code, if you have that as part of the data for the specification, it'll just go out and read the URL for the data. And then this values thing, what happens here, values is actually a Vega Light field for data sets, but it's mapped to this val data so that val data can either read a file or just take the inline stuff and then substitute it in. So that's kind of why that's where it is. So if we do this, now the thing is, all these things are mapped to this none. So if we go up here and we transform the data options, we're just going to get nothing because all of those guys go away, which is what you want, because now what we're going to do is transform this specification, this thing over here, and when we give it one of these substitution keys, all the rest of them go away and you get a legal Vega Light data specification. And the same thing if you had the URL, you get that. And so these things, that's how this stuff goes. Let's look at one of these fragments that templates are built up from. So this is the Viewbase in Vega Light. I think Christopher talked about this last time. It's built around this idea of views, and views have encodings and transformations and all this stuff, and you can layer them and all these kinds of concatenate them, whatever. So there's a view. So there is this fragment in the template system, Viewbase, which it's a value over here. You can see it's just a bunch of these specification keys that are legal Vega Light fields for a view, and then they all have these substitution keys. And here, for example, and then there's data down here, which has this set of transformation keys. And the deal is that all of these have defaults, and most of them are removed. Most of them are, but not all of them. Because if we look at encoding, encoding is one of these things. It's going to be another lot of stuff. All right, so what we have here is default encoding, which is for X and Y, and all these fields are part of the things that can be part of one of these encodings. So you have the actual field that for Y and the field for X. And so these things would correspond to, in the data set, something like horsepower or miles per gallon or something like that. And so that field would then immediately be for the Y. And then we have the type, and a lot of these things have defaults, like the typical default for these types is quantitative because most of this data is that. Then you got binning and aggregation and all this stuff. And so if let's see what we're going to do here. Okay, let's clear that out. If you can't really see too much going on here. Okay. And if we do this, we'll see that, and what we're doing is here's the encoding with just the default substitution key values. So all of that stuff in the original encoding most of it is thrown away, and then you get these fields. It's expecting by default that the Y field is called Y and the X field is called X, and they're both quantitative, and then you get this tooltip, default tooltip. All right, and then I could talk about this user data thing. I think I'm going to talk too much about this really, but the user data is, there's a special key that the IDL folks have provided in both Vega and Vega Light called user meta. And the user data thing is always in all of these templates is mapped to this tab, to the user meta. And what it is a trapdoor, if you will, for applications to be able to specify all kinds of stuff associated with a specification that have nothing to do specifically with the visualization specification of the Vega Light or Vega. So it's usually control data of one sort or another and all of that kind of stuff. So in Saite's case, which is what we're in here, you have the tab has a bunch of options to it. There's a frame. The frame describes things, all these picture elements that we're going to talk about in a bit, and the position and all this stuff. And so it's really all this control data that the application can pull out of the specification and do stuff with. That's all I'm going to say about that, I guess. All right. This is another example of a function. That's the value of substitution key. Here's the source. So what's going on here is this is the tab is label, which is like if you look up at the top here, these are the labels for the tab. There's an ID, but then there's a label. And the label is typically going to be kind of a human readable or sensible thing. And the default for doing this is you take the ID, you get its name, and you capitalize it. So it's expected to be like a keyword or basically a keyword or a string. All right. And so if we look at this PID, its default is explore 1. That's an old thing. It probably doesn't make any sense anymore in the current new setup, but that's how it is. So if we now look at the transformation for the label, that's what we get. Okay, so we just run the thing, and what happens is PLBL is noticed to be this function, and then it's run, and then the final result is what's substituted. All right, so let's take a look at a Viewbase. Well, we already looked at Viewbase, but we're gonna like transform the thing. So this is what you get if you just take all the defaults. And it always has this user meta, and here's all this junk from the user meta. But we can actually probably just get rid of that for the sake of looking at things. Oops, wrong. Uh-oh. Did I just lose my window? Oh, Chrome, you killed me. Okay. Yeah, I can get this back. I have to. This is one of the things when you're in the browser, some of these keys are not what you think they are. And I'm running in a sandbox here. So actually, you'll get to see something. You'll get to see a little bit of something going on here. Go back to this. And well, we'll get to see a little bit of these tools. Let me get it to the whole screen again. Fortunately, I'm going to go over here and just pull this thing back, and there you are. Oops, we're in the wrong place. But here's where we were. Yeah, that was really bogus. Okay, this is where we were. All right. We're in the wrong place. Where am I? I want to be in Viewbase. You lose track of things. And next thing you know, everything's gone. All right. Well, all I wanted to do is get rid of. Actually, you know what? I think I can do this. Yeah, there you go. That's another thing I put into the editor. You can delete F's expression. All right, so this is, without that user meta stuff, this is really what happens. This is what you get. And one of the things you'll notice, though, is the data is gone because you haven't done anything, and that transforms to an empty map, and so the empty map is removed, and that's the end of it. So but here's the default encoding sans the data. And there's these default widths and heights, and you can change these widths and heights in the substitution keys to be as big or small by default as you want, and then, or change them specifically for any given visualization. Actually, we'll see that in this tab, this next thing over. All right, so if we give this thing the data, let's just get rid of this thing. Let's get rid of this stuff again because it's actually you can even do undos. Let's get rid of this. So we can sort of see this thing. So now everything is basically the same except you have this data. You have the legal data field now. So we're actually, this is pretty close. It's getting fairly close to a legal Vega Light specification. And if we look at point chart is basically all you have is the Viewbase. There's part of it, and then the rest of it is down here, and with a mark. That's it. And so this one is circle for points. That's the Vega Light term for point chart. And if we look at bar chart, you'll see it's exactly the same thing, except that the mark is bar. That's it. So there you go on that. Now, so that means if we take like point chart, we give it a data source, and then if we didn't have any different names for the X and Y values in that data source, we could just let it default to the X and Y. And then we can have a complete legal chart that's built up of all that stuff. And there you go. So that thing is kind of like the typical scatter plot that's in all the big Vega Light stuff. And Christopher showed some of that. That exact example, it shows up everywhere. So anyways, if we were to take this thing now and actually visualize it, you would be that scatter plot. All right, so here's all the defaults. These are all these defaults. Substitution key defaults. Okay? There's a bunch of them in here. And what we're going to do is sort of show how you can use this transformation capability. We'll also do these. Let's see, we can require a couple of things here. Okay, so we're going to take those defaults, and it's an atom, so you're going to deref the thing. And then what we're going to do is we're going to change the keys to be lowercase strings. And then we're going to invert that map. So let's take a look at sort of what a bit that is. So, like column goes to column, X unit goes to X unit, but these lowercase strings. The idea here is we want to get rid of all this uppercase stuff. So if we now, yeah. Whoa. Oh, right. Exactly. Okay. Yeah, that's doing the wrong thing there. So we've taken the Viewbase and turned it into this. So from then on, you could just use everything like you did up here with Viewbase, but instead of capitalized view data, it would be lowercase screen view data. And things would just work the same way. So you could then change all of these things like that. For as an here, let's just show. Yeah, let's do the entire point chart as well. Yeah, so there you go. So the idea is that you could then either have your own namespace and templates, and you transform all the default ones into this kind of stuff, and then you're on your way. All right, so that's a kind of a idea of how templates can be used to abstract over all these visualizations. So let's look at tabs. So first, let's just go over these things. The idea is that they're a way to do auto structuring documents, like sections, chapters, pages, however you want to call it. And that's what these tabs would end up being. So you can imagine these being pages where it goes on and on and on with a bunch of stuff, or sections, or chapters in a book, or whatever. So conceptually, tab just corresponds to this kind of stuff. Tab bodies are further structured into either columns or rows. Each column or row has an element count associated with it to control the automatic layout. An element is a picture frame, which is coming up next. It's up here. You can have wrapping functions. This supports embedding the bodies of these, the tab bodies in application-specific controls or other kinds of layouts. And in fact, that's exactly what these tabs are. In particular, this interactive kind of tab here, where you have an editor over here with a markdown for all of this stuff over here, and then you can have visualizations with this as well. So this is an example. This thing here is an example of one of these wrapping functions implementing this capability. Yeah. Oh, there it is right here. It's similar. Okay, and then you can also have extension tabs, and these things are where the body is completely user-defined. You don't have any of this automatic layout or the idea of rows and columns and all that stuff. You can do whatever you want with it. You don't even need picture frames. You can do anything. And in fact, the idea here is you can just have your own layouts. But the cool thing is that the tabs, when you move among them, will still auto-render. So you'll still be able to make use of the auto-rendering capabilities of the tab system, even though everything is completely done the way you decide to do it. An example is this Saite convert tab. So this thing basically takes JavaScript or JSON as a Vega specification, or it could be any JSON as far as that goes. But typically using it for Vega Light, and then you can convert it over here to corresponding Clojure. So that you can then take that and use that as a start for your template, some new template, or you can just take it and automatically render. Actually, I haven't. It's probably worth even doing this. Let's see. I have this example, which is taken from the Vega Light galleries, kind of backside thing. So you just scoop up the spec, come over here, and let's paste it in. So this is a code mirror window that's JavaScript or JSON, the style of the editor. So, and we can just convert this thing directly over here to the Clojure, and there's a tool over here that I that you guys are covering up. Well, let's see here. I tell you what, maybe if I do this, you can still see it, but one of the you can go the other way too, which is really, really handy at times. If you have a specification that you've been working on and it's kind of not working, and you want to generate something for the IDL people, they're going to want to look at it in the standard JSON. Anyways, though, you can then just pop this up. So the other thing you can do, so this is an example of one of these extension tabs which has nothing to do with the normal tab layout stuff or anything. The other thing you can do is you can convert the thing first to Vega and then over to Clojure. So now here's this thing as Vega. And that can be useful at times because you might be in a situation where you can do some of your spec in Vega Light, but then there's bits that Vega Light does not have, that are not yet, well, let's put it this way. Not everything in Vega is going to make its way into Vega Light. But there are times when you're going to want extra kinds of signals and things like that that you can do in Vega, but you can't do in Vega Light. So you start with the Vega Light thing, generate the Vega, and then just add the little snippet. So that then you have a complete legal Vega Light, a Vega specification, and then you can just render that. Anyways, so there you go. So that's an example, though, of this stuff, this extension tab stuff. All right, so let's open this up. Well, let's go back to full screen. So open this up, and now we're going to fool around with some of this layout. And first thing we're going to do is, let's hold on to those width and height. Let's change the width and height because we're going to want them to be a bit smaller. And if we come here, so I have this mapped to Control X and Control I, or if you have a full keyboard, it's insert. So if you do Control X, I, you got your chart down here. This is your basic scatter, that basic scatter plot chart. We're basically visualizing that thing that we originally saw in the templates. Here it is, point chart. The only difference is we give it a frame ID and a video, visualization ID. And we can just keep going on with this stuff with different ones. There it is with a binned bar chart. Same stuff. And here it is with the lines, but with smoothed out lines. Oops, I did something wrong. There it is. And this again, this is some of this. This is the exact same stuff Christopher was showing last time, but now using these templates. So here's the bin, here's the aggregation, and if you look at that, you can actually look at this because this is a REPL-based thing. It's just that the output is not very big, but you can render this stuff over here, or you can just execute the form and get the value. So now you're just getting the actual value of this thing. So this is the actual standard. This is what you was Christopher was typing in when he was, except for the user meta stuff. But like the mark, the width, the background, the different encodings. Hard to see. Yeah, it's up in here. Here's the aggregate mean. Bin true for the X. That's the stuff you would normally have to type in. Okay, so let's just keep going with this a bit further, and then we're going to click around.
Sorry, John. Can I just interrupt for a second?
Yes.
With the Xform thing, that's been run on the server, isn't it?
No.
It's not.
No. Not one thing we've seen this entire demo is run on the server. Nothing. It's all self-hosted Clojure script.
Huh. But like, can it be run on the server?
Oh yeah, absolutely.
Okay.
Everything we've done so far, you can do on the server as well. Yep.
Okay,
and
cool.
Push it, and just push it over here. Yep.
Yep. Awesome. Cool. Thanks for that.
Yeah. So here's a layer chart. We got all this kind of stuff where we layer these things, and we got the opacity and all this stuff. Actually, the opacity, color, shape are an interesting example of substitution key that has a substitution key function. And the substitution key function is like metadata for substitution keys. And what that really boils down to is when the transformer finds one of these things and says, oh, this guy has a substitution key function, the first thing it does is it takes the substitution value, the current substitution map, passes it to that function, and then that function decides what to do with it. And what this is doing here, this is a bit like altair. You will see in altair something like color origin, okay, in one of the method calls. Actually, we could probably pull that up, but and what's going on though is it's being in the altair. I don't exactly know what's going on, but it's a method call. But here, what happens is this thing gets transformed into a map where the color then is got the origin. In order to be the legal Vega Light specification. So it's not just taking color and giving it the string origin. It actually turns it into a small map with the correct field and all that kind of stuff. And same thing with opacity. So it's an interesting thing. It's a metadata thing on substitution keys. So you can have substitution keys that are function whose value is a function, and you can have a substitution key metadata thing called the substitution key function. All this junk comes in handy in different circumstances. And what is this and why didn't I don't know. Let's just put it up there though, because the important thing with this, oh, I know what it is. It's faceted. Yeah, it's faceted. So here's the, yeah, it's called that. Yeah, so it's a faceted thing. So we got all these things here. Now, actually, let's just move this out of the way. Now, if we come up and we can edit the current tab. Okay, I don't know if you can see this. And in particular, what we can do is we can, okay, let's change to column order. So now all this stuff is over here as columns. And since it's one per column, well, you're just going to get that, a bunch of columns all the way, because we only got one element per column. But we can change that if we want, make it 2. So now we have this stuff, and then we have these 2s over here, and yeah, there you go. Well, and then you can also flip that back. Maybe we'll take 2, but we'll do it in row order instead. And we can change the label. Probably don't want to, but, and we can change the namespace for the editor. Yeah. So now it's, there's 2 here, there's 2 there, and there's 2 there. So you sort of see how you can fool around using these layout controls. All right. Picture frames. So picture frames, They're the basic element for these tab bodies. So we can go back over here for a second. Every one of these things is a picture frame. It's just, okay, every one of them. The only thing is, these picture frames only have a visualization. They don't have anything else. They just have this thing. There's no top, left, bottom, right panels. But that's what you can do. And those all these panels can be any kind of thing like hiccup, strings, markdown, LaTeX, whatever. Yeah, they can be all, in Saite, they can be, well, in Saite, the markdown can also include LaTeX. I guess that's the important thing. Hanami specifically doesn't include LaTeX because you need math jacks or something like that. And it's just too, it's a weird dependency, and it's complicated. Actually using math jacks with React is kind of a mess. You have to monkey patch the thing in order to make it work. So it didn't make any sense for Hanami to have that. But if you want it, you can do it, and the Saite actually has LaTeX capabilities in these frames. Oh, another one is probably worth noting is, yeah, let's take a look at this slightly different. Over here, this whole thing here is a picture frame, but it only has the top element. There's no visualization, there's no viz, left, bottom, or right, but it has this top element. That's what all of this markdown is. That's what that is. And we can take a quick look at that. So there it is. This is the markdown for this thing. And here's the little specification for it. Here's the top, here's the gap, here's the width, here's the font size, blah, blah, blah. All right. So that's some more stuff about picture frame, how that works. The thing is in these interactive, now if you're pushing from the server, you have all the same capability, exact same thing. The only thing is that in the server, you don't actually need these frame IDs or video IDs. I keep calling them video IDs, visualization IDs. But in these interactive docs, if you don't have them, then it doesn't, some of these editor keys and stuff won't really know what to do with them. So they'll just sort of be sitting there dead in the water. So there's an issue that, well, we'll get to that in the future. It's about, you know, how to, maybe these should be generated instead of having to put them in yourself or whatever. Also, frames can be added in bulk, okay? Or they can be added incrementally. It used to be like, for example, on the server, you might want to really do this in bulk. And I would have an entire set of these things inside of a do and just blow the whole thing over to the client, and it would all generate all these tabs and all this stuff. And it just, yeah. So you can do it both ways, but in these interactive kind of scenarios, you generally just are adding individually as you go along. And then the panel parts, in particular the viz, can be updated independently. And that's kind of nice. That's a handy thing when you're doing this interactive stuff. All right, on to the next, Saite. So a little brief history of how this whole silly thing came to be is this. So originally, this thing was just a cleaned up variant of all these different server push-to-client libraries. That's what it was. It had the big thing about it was this message system, which was much simpler and cleaner, even though it was in some ways even more potent than the typical ones, like in Sente. And then it was like, well, you know, I'm using this thing, and there's highly repetitive visualizations. You can see where you could abstract this stuff, but it was tons of cutting and pasting in order to generate a bunch of this. And it became, this is crazy. So how to fix it? Well, you know, the first thing you think of is, well, I'll define a function for my little thing and that abstract, and I'll pass in parameters and all that. Or maybe it's methods, or how about protocols? Maybe there's a way to do the protocols and you do extensions constantly or something, who knows. None of that stuff works very well because you always end up writing code and you have to change things. The first thing that comes along, you forgot a field, or it's this or that. But then it dawned on me that, well, this stuff is just data. That's one of the great things about Vega and Vega Light. It's just data. And so why don't we leverage that? And that's where this idea of templates came from. And then they became, in the beginning, they were really simple. There wasn't a whole lot to them. They worked. There wasn't even any real default substitution keys or anything. You just sort of gave them in line, and it all kind of was whatever. And then it just became more and more, sophisticated. You got like those metadata functions and all that stuff. Anyways, the other thing there that kept hitting was highly repetitive layouts. It would seem like every time I turned around, I was writing the same or similar kind of hiccup to sort of lay the page out. And I was like, why am I doing that? That's crazy. So, and generally, applications have these two levels of organization. There's pages and then the bodies of the pages. And so that's where the tab system came from, and that's automatic body layout. That's sort of how that evolved. And then it was like, well, why can't I have nice integrated external controls? Well, sure, why not? And that's where Recon came into this thing, and reagent and all of that. And then it was like, okay, now this thing is becoming kind of a mess. Is it an application or is it a library? Who knows what it is? And so I split out all the library-like stuff into Hanami as a library, and then the Saite application became the rest of it, and has just kind of grown from there. So like, yeah, LaTeX, editors, save, restore, blah, blah, blah. And so that's sort of how that came about. And this is kind of the current state, more or less. It's still changing, but you now can have picture frame panels that can include editors, okay, for the central visualization. So you literally, in these things here, the top, the left, or what, you can make those editors. You can make those editors if you want, if that made any sense. Now that you have these interactive tabs, I don't really use that much anymore, so maybe that doesn't even mean anything anymore. But the big thing now is you have these editor-enabled interactive tabs, okay, which are basic REPL type, like what we were seeing with this template thing. Basically that kind of stuff. Oops. That's a bug. This is actually a bug. Not supposed to do that. Okay. But you can also have these interactive document types, which is exactly what we were seeing, like with the tabs. This stuff, all of this stuff. So you have a left side. And it's actually customizable. If you don't like the left side, we'll see that in a second. Where you have this editor, and then the document layout is in the right. This is sort of like, if anybody's looked at Iodide, it's similar to that. Okay. Oh yeah. The other thing is you can have namespaces per tab, which is kind of nice to isolate code. I think Daniel mentioned something about, in terms of being able to duplicate something and then change the stuff and keep the original in terms of data exploration capabilities. So you can do that and then put them in different namespaces so they're not stepping on one another. So you then change the values and stuff in different ways. But they can also span tabs. Like every single one of these things is sitting in the same namespace. It was just convenient for me to do that. You have save, restore capabilities. These things up here. We've seen these. We've seen these by accident because the thing Chrome killed me. Yeah, you have this interactive tab manipulation with all these controls up here. So you can add an interactive tab, you can duplicate the current tab, you can delete the frames, there's undo and redo stuff. You can move these things around. I mean, for example, I don't know if you want to do this, but we can move this. This is the wrong thing to do, but you can see we're just moving it along here. Let's put it back to where it probably ought to be. And then you can edit. We've already seen that about changing these things. And you can delete this stuff. Probably don't want to do that, but let's delete this. And then let's do an undo. Yay, there we go. So it's back.
John?
Yes.
If it is a good time for a question,
Yeah.
Could you explain what just happened in terms of the data model behind the scenes, in terms of the state of the application?
You mean like when I deleted and redo?
Yeah.
What happens is, this is the nice thing about immutable data. What happens is the current tab structure is pushed on a stack, and then the change is made, and again, thanks to Spectre, it just automatically creates a new value in the atom, but that value is sharing almost everything else with the stuff that was previously there. And when you do an undo, all it does is just swaps that thing that was that last thing on this push. It just swaps it back in. That's it. So there is this state manipulation, but again, tip of the hat again to Nathan Mars and Scicloj for making that just really simple. Because these things are pretty nested. There's a boatload of junk associated with all this stuff, and there is a lot of nesting. And if it didn't have that capability, it would be a mess. Okay. So those are those, formula diamond level markdown. Oh yes. See, it's just like what we're looking at right here. It's like, how should this be? How should, I mean, right now I'm just doing this, but you can imagine getting rid of, certainly you can easily get rid of X1 in the actual inline editor. And you can get rid of this silly thing. Maybe you automatically generate the the frame IDs and the V IDs for everything. Maybe the default is always top, so you don't need this, but you could include more. It's a little, I can show you actually a little bit of what that might look like, and I have some experiments with it, but I mean, the idea is how to make that look. And then there's configuration and customization. There's now it expects a .site in your home directory, and inside there's a config file, and you can have your data paths in there for reading from the server and saving the documents and all that stuff, like with this stuff here. All that's kind of editor keys. How do you want to configure the editor capabilities to key sequences? All that junk is in this thing here, this customization configuration stuff. And then there's a various server-side Spartyball where you read files. All that kind of works fine now. Mix server code and client code together. So if somebody was wondering, is some of this going on the server? And the answer was no. But you can certainly imagine in many cases where you would want to mix server code with this client code, because you don't want to be running some jumbo thing, crunch to produce data, in the browser. I mean, it's probably just a dumb thing to do. And so it's much better to be able to just automatically know when and how to run the stuff over in the JVM. Oh yeah, auto syncing and namespaces. So all these things have namespaces, and then they're echoed or mirrored, or however you want to say it, over on the server side. So if you were to invoke this server code, it would have the same stuff over there that you could. So it would be, you wouldn't get unexpected errors because the unknown bar or whatever. All right. Future. No particular order. There's a lot more editor stuff that can be done. Certainly, I want at least slurp and spit S expressions. I really miss that. And it's definitely doable. I mean, the really cool thing is, and actually a lot of the stuff with the CIDR keys that I put in place, and stuff even for like inserting and deleting picture frames in these interactive tabs, uses a lot of the Emacs code mirror support. I mean, there's a surprising amount of pretty nice stuff, S expression stuff in particular, in there. And then there's support for other editors. CodeMirror has support for both Vim and Sublime, but I don't really know much about these things, so I don't know how to put the key maps together. Maybe somebody else could do that. I don't know. There's this whole block markdown thing. This is this business of like, what should the editor content look like in these interactive tabs? I mean, like I say, right now it's like that, but it could be a lot of different stuff. And I have, and like I said, we'll pull up another one of these things, and we can look at a little bit of something. Big one that I really want to do is integrate Neanderthal and now Pantera. I mean, this right to me is no-brainer stuff that needs to be in there. I mean, the idea is that these things would be like turnkey support. So in case of like Neanderthal, the MKL libraries would be included, and then they would be stashed so that you'd be able to find them and all that stuff. Then there's other language support. Python. Hanasu has a Python implementation. But maybe that's no longer relevant because you have Pantera. And maybe that didn't make any sense anymore. And same thing with this with R. I'm really looking at this R interop stuff. That looks like something would be really great to integrate with this thing. Or maybe there's an R Hanasu, right? That doesn't exist, but so it's unclear. I mean, the only advantage now of Python would be, well, you could write Python code. Maybe nobody cares. Why would you even care? All right, Cytoscape. I want to include Cytoscape because it has much more sophisticated interactive graph capabilities. I talked to the Vega, the IDL folks, Dominic in particular, and they said, well, yeah, that's something, but you know, it's low priority. We don't really care right now. And since this thing, Cytoscape, has an enormous amount of capability, it's just kind of amazing how well it works and what it can do. And maybe the right thing to do is just pull this in. And then maybe there's other visualization libraries or who knows what else. And then, yeah, a full self-installing jar with a REPL and REPL sort of support for server to client. Okay? Or if you want to plug in with your Emacs or your Cursive or something. So you can do server-side things directly. And that's kind of that.
And there was a question, John, there was a question in the chat about, curious about the editor component, wondering whether that was a standard recom component.
Which? These things?
Yeah.
The editors are CodeMirror. The CodeMirror editors. they're embedded. Okay, all of this stuff is done with recon components. See this splitter? That's a recon component. That's what it is. The editor itself is CodeMirror, and there's a Form 3 reagent component that does these editors. The other thing is these editors, there's a lot of junk that needs to be done because there's the input and the output, and that stuff has to be tracked because when you save it, you want to save this current state and all that junk. Yeah, and then there's the keys. Those keys right now, there is this business of doing the configuration where you have the key sequences mapped to particular editor capabilities, like, let's go over here for a second. Yeah, like this stuff. So, for example, I mean, I have literally the, if I put it at the end of an S expression, actually, let's do this. Let's put it there. Control X, oops, I don't know what that did. Oh, actually, that's a good deal. That's worth knowing because you also have, I mean, these things are more like real editors. So I can do a Control S and search for things like, or let's see. Yeah. And you can do regular expression replace as well. Same kind of thing. You can do that. So it's like a real editor. Okay, you can have cut. You can like scoop. You can do like delete. Let's say delete this S expression. I just have it mapped to option K. But you can undo. Just like literally, and it's the same key sequence as an Emacs. And then I added these things like Control X, Control E to evaluate last S expression. So down here in the origin, there's this. This is the output REPL down at the bottom there, as you can see. Or if you do Control X, Control C, it'll evaluate the entire outer S expression. Now that just evaluates that form, which does the transformation in this particular case. And then I have, so what do we have right now with this crazy thing? Let's go back to row order. Let's go to 1. So we're able to see what the hell's going on. All right. So I have Control X. Well, if you have a regular keyboard, insert, delete are mapped to these insert and delete operations for the visualization. So thing is already there, but if I do a Control X, Control D, it goes away. I can put it back, Control X, Control I. And it's smart enough to know where these things go. So if I take this bar chart and do a Control X, Control D, gone, but if I put it back, Control X, Control I, it goes back where it's supposed to be. But if I move this piece of code to this bar chart, if I move the piece of code to the bar chart, let's actually do that. Then I can scoop that up. And let's just for the heck of it, put it here instead. Okay. Oh, that's something that's something that's coming. Is when I scoop that out of the editor, I can make that also instantly delete this guy over here instead of having to manually do it. But if I now put him in, it knows where it's supposed to go. So you can do that kind of stuff. So so the editors are pretty, I would say the editor could be arbitrarily strong. There's no, I mean, the amount of capabilities that you have in Clojure is pretty amazing. It may not be quite at the level of like eLisp or something, but it's pretty much anything you want to do, you could probably do. So that's what they are. That's what those things are. They're embedded in all these recon things, like this slider here for this. And all this stuff, all these tabs, those are recon components. All these buttons, this is material design, that's automatically included with the recon stuff. Yeah. I mean, let's take, it's like if we go over here and we do like duplicate, we can duplicate this thing. You know, we get, okay, what do we want to make this? You know, we can make it, let's just make it whatever it says here. It's kind of stupid, but whatever. We do that, now we have these things, okay? Nice thing about that is you don't have to think about how to make that. But and again, if you can do, just get rid of that, and then I mean, this is just kind of sort of how I put this silly thing together. And let's we can just cut that, whatever. Yeah, there you go. Yeah.
Cool.
And then we can just delete this because it's not really useful. Here's how you actually start these things. So you can create an interactive doc, which has the let's get out of that. So, yeah, it has the editor and the body. So you can, that's what this is. And you can create an editor REPL thing, which we saw with the template demo, walkthrough, whatever. And you can create the number of elements. There's the ID, the label, the namespace for the tab. Maybe default to this doc.code thing. There's all these other options, the editor width and the layouts and all this stuff. Yeah, whatever. There's, yeah, if you have a bunch of things, like in this tabs example, I mean, walking through this stuff, maybe sometimes it's easier to just, you can just select these things and delete them. It's a little easier than going through the code doing Control-X, Control-D, or whatever. What else is? Oh, and then we already saw the do and undo, the left, right, the edit, and the delete. Yeah, so that's about it. That's kind of about it. One other thing that might be worth pulling up. Let's just pull this thing up for a second. I think this thing has, yeah, I mean, this, you can see some of the LaTeX here. And this is an interactive control, external. Other people have seen that before. Chapter 1. And you can have images. I guess we already saw that before, but anyways. Yeah. Oops. Yeah. Maybe this. Oh, you know, this has got a slightly interesting thing. So this is actual real work. We got this new nanopore sequencer, which is these little bitty things. They're maybe about this big. Yeah, something like that. It looks like a ice cream sandwich. And they're for, I mean, the primary idea is you can do sequencing in the field, and it does streaming stuff. It's doing the sequencing in real time and streaming the data out as FastQ data in real time. It's pretty cool. There's some neat things about it. But it does have lots and lots and lots. It has a lot of read errors. But anyway, so we've been doing experiments with this stuff, and this is some of it. This is just a little bit of fooling around. But this shows reading from the server, from the server. So we just execute this. Yeah, one thing that's hard to make this thing do is it's because you're sending these messages back and forth, and everything is asynchronous, and so the only way I figured out how to do it is to actually it's in a Go block, but the thing that's returned is this volatile. So when it first does this, you don't. It's because it hasn't finished doing its thing, but now you can actually see the actual values. So it's going. You can sort of see this thing that briefly flashes over there. It's supposed to be a spinner. It happens so fast you can't see it. Yeah. So now if we count these things, you can do stuff with it. Blah blah blah.
So, John, which parts of these are JVM Clojure, if any?
The only thing, yeah, that's actually a really good point. This stuff here, the calculation for these distributions was done on the server. It was in the JVM. Yeah. Yeah. But the rest of it is just self-hosted stuff. So here you have, you can do your overview. Kind of cool. You can just repaint just the visual. So here you have some text associated with this thing. Yeah, the top part, whatever. This is a work in progress, but the problem with this thing right now is most of the data is rRNA. It's contaminated, if you will. So the biologists have to figure out how to fix that. I think that's about it. Unless you got questions. Let's go back to the present. Oops, let's go back to the presentation. There we go. Actually, this is probably the right thing to have it on. You know. Like, I mean, the thing is I don't know where this thing should go exactly either. I mean, some of this I want to do. I mean, certainly this stuff with Neanderthal and Pantera, I think makes a lot of sense. Cytoscape, there's a colleague that wants this, so that'll probably go in. And yeah, there you go. And if anybody has ideas or suggestions or wants, I guess those would be things too. And I mean, you can file issues, and yeah.
Can I ask, John, about the client and server? So there could be different ways to get the server involved in this user story. One could be just stateless computation. And another could be like a whole REPL session in the server that is connected to what is happening here in the client.
Right.
And I wonder what you meant. And I guess the other kind, the REPL kind, is interesting, but it complicates the redo undo story and all that, right?
Well, okay, here's my feeling on this has evolved to where I no longer use the server to push things, visualization. The server is becoming, I mean, you can still do that. It's all there, you can still do it. But the server for me is becoming, it's the data source. It's the thing that computes the data. And then the client, all of visualization, all these components, all that stuff is in the client. And so there's just the data streaming back and forth. And this idea of having server code implicitly run, maybe it's not 100% implicit, but you know, where you can have a piece of the code in one of these code mirror editors. Maybe it's a key sequence, you know, it's some fancy key sequence that says, don't run this in the client, don't try and run this in self-publishing Clojure script, go to the server. Take this hunk of code, go to the server, run it, bring the results back. Or maybe there's a flag on that block of code that indicates, oh, this is Clojure, or this is Python, or whatever. And then it goes and does that and brings the result back. But the idea of pushing the visualizations and the markdown and all that stuff, I don't use that anymore, and I don't like using it anymore. Even though in the beginning, I liked it. I did a lot of that. So that's sort of my view. So what happens then is all this tab stuff, do, undo, the state, all this stuff having to do with the state of the client, you wouldn't need any of that on the server. The server doesn't even know this exists. It just says, I don't know anything about that, I don't want to know. It's kind of like Rich Hickey. I don't know, I don't want to know. Yeah.
Does anybody have any other questions for Jon? Either in the chat or switching your audio on.
So I will ask for now, if that is okay. So you mentioned Emacs several times, right?
Yeah.
And I wonder how more Emacsy it could become. I mean, you have a system written in Lisp, and all the state is accessible as data. So maybe you could have the user write some Lisp that manipulates the state, like in Emacs, right? Would it be interesting?
You mean like eLisp?
Yeah, like the wall of eLisp in Emacs, like maybe manipulating the tabs in Clojure script on the user side.
On the server side?
No, everything on the client. The client is like Emacs.
Yeah.
And then the user could write some Clojure script code that generates 1,000 tabs or something, right?
Yeah. Yeah. That's absolutely true. Yeah. Actually, you can do that. Let me see if I can find a. Probably have to go back to. Oh, this is. That's probably worth looking at too. But actually, let's take a look at. Let me see. So these are just things I was experimenting and fooling around with. Yeah, see, this has already been changed. Let me see if I can find an old one. No, they're all changed. Yeah, that's hard to believe. Let's go, let's try, maybe it's in here. No, but I mean, the point is that all these things used to have direct calls to this function called add to tab body. And that's much more at this level that you're talking about, where you can literally just build something and then blow it all out. Exactly. You could have, the other possibility is that, well, I thought about this too, is like these things are just code, and you could wrap the entire thing in a do. And you could have as many things here as you want. And then it would just generate them all. And you can use there is on the client, there is the exact analog of the server's BIS, exclamation point, which says, oh, take this spec and put this tab information and push it over. Well, on the client, there's an exact analog of that, and it's called BIS exclamation point, and it kind of requires. I mean, you could wrap this thing in a viz with and change some of the tab, change the tab ID and some other stuff, and you could just generate them all like you're suggesting. Yeah. Yeah. Another thing that's I know how to do this. I even experimented a bit with it. Yeah, I mean, here's an example. I mean, this is just off the top of your head example, but I mean, this, like when you save something, I've looked into how the Vega guy, the IDL folks have encapsulated this stuff, where they have the file name and all of that. And it would be pretty straightforward. I had kind of an exploration sandbox version of it, where you could then give all these charts. I mean, if you click on this and you say save, right? It's saved as something like visualization, PNG or SVG or something like that. And that's because that's the default name they use. And they don't have a way to name these things. But it's pretty, I looked into it, it would be very simple to change the name. It's just a paragraph in a div. So you can change that, and then the saving itself is directly callable. So you can just have all these things go to a chart directory with their names, blah, 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 blah. Or maybe it's a chart directory organized by tab. So the tab name is a directory underneath the chart general directory, and then all these visualizations would be their names in that. So you can just save them all in one whack. Yeah, you can do that. I don't know if there's anything else there. Oh, wait a minute. There is one other thing. What is this? Yeah, this is where I was experimenting with some idea of how to do this meta markdown stuff. So, oh, this is going to be markdown. And then this gets translated into, the editor will take that and transform it into one of those markdowns with a colon top or a colon bottom, whatever, and generate the stuff. But here you just don't have to write all that stuff. And the same thing like with this. There's disadvantages to using this technique though. I don't know, I had some experiments with the code in the editor, you know. But this is that format stuff that people were talking about. You know, like what is there going to be some kind of lingua franca for these kind of meta markdown indicators or something?
Maybe just to comment about it, that is a discussion that began about a couple of months ago when Martin Kavala of Next Journal suggested that we could think about a proper export-import format where we could communicate between the various tools like Saite and Next Journal. And we haven't finished that discussion yet, and we are very interested in that, in thinking about whether we could have one language or two maybe that most tools could use to communicate and to have like a standard way of representing a visual document, say.
Right. Right.
Would you say this is a Clojure app or a Clojure script app?
It's the way it is set up right now, it's both. Because it does use the server for obtaining data and some of that kind of stuff. And it will use it for computation purposes when like Neanderthal and Pantera and some of those things are integrated. Or it could even now, as far as that goes, I mean, that stuff with the nanopore sequencer, that was just done in the JVM. I mean, it took a while, but it, you know, to crunch through. I mean, there's the raw data from the sequencer. There was, you know, several billion reads, but it, you know, the JVM went through that pretty okay. But doing that in Clojure script would be crazy. So, so right now, I think it still has that server piece to it. Yeah. But most of the manipulation is now in the client. I used to always like hook up my Emacs to the thing and then do all that kind of stuff from Emacs and push charts and stuff like that over here to the client. And like I say, you can still do that. As far as that, that's still doable. I just don't typically do it anymore.
Like I feel like the apps sort of that there's that website. What was it called? I lost it. It's on chat. Whatever is it? iodide.io. I felt
right, yeah, the Mozilla guys.
Like, I mean, is there any, like, has this replaced your workflow, or is this like, is this something specific that you were looking to do with this, or like, I'm very curious because there's a lot to this thing, and I mean it's sort of, it's almost like the start of like, it's like you can put a lot more widgets on there with how sort of flexible the templating system is. So I'm like, I'm not sure where you're going with this, but it's really cool. Like, yeah.
Well, I'm totally with you on that because let's go back. I mean, yeah, I'm totally with you. I mean, the history and stuff sort of indicates how it came about. And I mean, and there is all this stuff. I'm like, this is not a complete list in any sense of various things that can be done. So I'm totally with you on the idea that there's a lot of potential. It's just unclear exactly how to realize it. Maybe that's the right way to say it. I actually think this thing, I started doing this with the code mirror editors and stuff like that and experimenting before I saw iodide. And then when I saw iodide, I said, yeah, that's kind of cool. That's sort of the way I sort of had envisioned these interactive documents as well. You will notice, I mean, this thing is very different from a standard notebook. Just like iodide is very different from a standard notebook. In that you have a REPL. You have this REPL-based interaction that's just continually going on. It's not modal, and it's not linear. It doesn't need to be linear, let's put it that way. I mean, you can do it across these tabs, and you can have all kinds of nonlinear layouts over on the other side. But the idea of the interaction and stuff with text, with images, with visualizations, and all of that, with controls, external control, all of that is kind of, well, actually stuff like external controls. I don't even know if you can do that in a regular notebook like Jupyter. I'm not sure you can. Yeah, because it's usually, a block is active and you do whatever you do, and then you sort of execute the block or save the block or whatever, and then it updates and does whatever it does. Whereas this is, no, it's just it's totally interactive in that sense. Yeah, yeah. I mean, this, yeah, I guess it was this one. This is the one where you can see a lot of that interaction kind of stuff going on with the visualization. So, and you just sort of do stuff. And then, if you got it to where you want it, the idea is it would be nice to have a button here that just says, get rid of the editor, hide the editor. Right now, I'm just sliding the thing over. Yeah, and then you just have this. First, or, who knows? I mean, there may be cases where, the interactive part is every bit as much a piece of what you're trying to communicate as the actual body. Yeah. And I guess that's another thing we're noting is like the template system and the transformer and all that stuff is actually CLJC. And it's, it's incorporated on the server and in the client. Yeah, and it's the exact same code. Again, many thanks to Nathan Monk.
Excellent. Any other questions anybody has for Jon? It's all silence. Oh.
Maybe if I can ask, Jon, how would you like people to help with that project? If you can think of ways where people could be helpful to what you're doing.
Well, maybe I think the way that would be helpful is things that would be helpful would be things like ideas of where the thing should go or how the thing should be refined and this kind of stuff. And maybe it would make sense to have a channel on Zula. Because having discussions about how this thing should evolve or you know, what this stuff should look like over here. And, I mean, input like that, I think, is really valuable. You know, how would somebody envision using this thing in their workflow? I mean, I'm using it now. I do use this thing in the workflow. I mean, like that nanopore stuff. That was 100% done in this thing, except for the actual data crunch of it.
Yeah, it seems there is so much to discuss now. It was really mind-blowing to see all the opportunities here.
Yeah. I mean, it was even these controls and stuff. I mean, this has changed over the last month. All of these things have changed and evolved. You know? And I'm sure there's more that can be changed and evolved as far as that goes. So I don't know. Yeah, maybe it would make sense to have a channel. Or there's the issues. I mean, the Saite GitHub, it's just people file issues there and start discussions with that. Probably a bit more searchable and easier for more saved or like preserved, I guess. I mean, Zulab doesn't lose stuff, but it doesn't throw stuff away. But it's easy to lose stuff. I went back looking for some discussions I had with you, Daniel, and I was like, where is this? And you're clicking all over and searching. It's like, well, I know it's there. I don't know. Actually, let me flip this around. What kind of impression or first impressions do people think about this? I mean, is it like, oh yeah, that looks kind of good, but you know what? I personally don't want to have anything to do with it. Or yeah, this looks really great. I wish it was, you know, already out there with the self-installing jar and multiple editors and all that stuff.
Maybe like I was really impressed because I feel like you've sort of put together a lot of components. Like I really like the Vega schema to CLJ, that converter.
Oh,
and
yeah.
I feel like that was really easily defined. Like somehow you just, you know, created a template, you know, did some magic, and then bang, like, you know.
Yeah.
I feel like there could be a really cool plugin system for this. So if you can imagine like you wanting to integrate all these things, well, you know, what if people don't need all these things? Is there a simple way to add like, you know, like a plugin system, you know?
That's actually a great idea. It never occurred to me, but now that you mention it, that sounds like an absolutely spot on idea.
And I feel like also some of the widgets, like I think, you know, they're widgets basically, you know, or like little utilities that do a specific purpose. Like some of the widgets actually need an editor. Like it might not just be enough to write code and, you know, have it display. You know, like you could really go to town with like an editor for the editor. I don't know how easy that would be, but you know, I think that the templating system that you created is great. Again, like I'm not sure how it works with the front end, because the Clojure script stuff, like I'm really bad with Clojure script, but I feel like if there was a way to, like, I feel, because I like Gorilla REPL, so you know, like I'm sort of used to things being pushed from the server to the client, but if there was, like, it just really reminded me of HTML widgets, you know, the what R has bought, but I feel like, you know, yeah, it's really exciting, and you know, if there was a way for a plugin system to you know, there was a plugin system, then that would really be something.
I like that idea. The plugin thing sounds like a really good idea. I mean, for example, maybe the first hack at that would be the Cytoscape. Yeah, because that probably is going to be a kind of discrete piece that could, yeah, maybe that would be the first thing to try to explore that idea of plugin. And you know what? Maybe that's also true for things like Neanderthal and Pantera. Maybe those ought to be somehow like that as well.
Yeah, like that's what I mean about it being, like, you know, whether it's a Clojure app or a Clojure script app, because I mean, it's sort of both, isn't it? But like,
it is. Well, actually, so is Gorilla REPL. Gorilla, except that it's not ClojureScript, it's just JavaScript, and kind of old JavaScript. But that's what it is. It's a client and server. The only thing is, you know, oddly enough, Gorilla REPL actually has code mirror, but it doesn't include any of the editor capabilities. It just uses it for highlighting. It's a very strange thing. I mean, you can't do things like, you know, move by S expression or cut by S expression or regular expression replace, you know, or search. You can't do any of that stuff. But with this thing, you can. I mean, you can literally just do it. Kind of like a real editor. It's pretty much like a real editor. Yeah. As far as that goes, even things like Control-X, Control-S, or Control-X, Control-F, you could easily map that to these things up here, to these things. The underlying stuff, the stuff that's behind this. Yeah. So all of those sorts of things, I mean, one way to look at this thing is that it's an interface. It's an interface to the data punching capabilities of a server. Yeah, I mean, that's one potential way of thinking about it. So even like the code for, I mean, like this thing. I didn't actually do this. I should have, but I didn't. Yeah, I just didn't. I don't know, where is it here? It's probably here. Yeah, like this thing. This widget up here is a recom. It's external. It's not part of this visualization. It's not part of the Vega Light, Vega specification. Now, this is kind of a dumb example in a way, was just simple. It was just very simple to do as an example. Because you can do sliders as signals in Vega and Vega Light. So this is sort of, you could easily do this as part of a Vega Light specification. No, maybe a Vega specification. You just, okay, and as you move this thing around, it's feeding the data channel. But this widget, the thing that makes all this work, was originally done in the server, and it was pushed to the client. And it's kind of it is actually kind of a messy thing. And worse than that is that the actual functions that make this work had to be written in the client. They had to be written in the client. So the only way to make, if you were doing this 100% from the server, now you would have to have had the code that drives this thing as part of the specification of the visualization, probably in the user meta, and then it would be pushed to the client, and then there would be a field in there called code or something, and the client would fish that code out and evaluate it, and then be able to do whatever. Now, you can just do that in here. I mean, you can write functions here. You can just write them. And so those functions that used to be would have had to be passed from the server as strings, or maybe it could have been symbols, because this thing, because Hanasu uses message pack, so you can do anything you want as far as that goes. It can be actual Clojure, Eden data, and whatever. But you still have to push that over and then evaluate it on the client side. That's the only way to make it work. You can't do it otherwise. It doesn't even make any sense. So, but now writing those functions could just be part of a code tab. A tab that has all the code, and you can save and restore it and edit it and do anything you want with it. Yeah. Maybe there ought to be, actually that's an interesting idea, maybe there ought to be a hide tab. So, if you don't want to, if you have like implementation details as code or other stuff, and you don't want those to be readily visible or something, who knows? I mean, that's another idea, I guess. That would be easy enough to do, I think. But the key thing is that kind of stuff now is nicer now that you can write actual functions and whatever. So the instrumenter for this thing no longer has to be pre-built as part of the client or pushed as a string or a hunk of code that gets evaluated over on the client. You can just have it here in the client. Yeah. So I kind of see this thing as it's an interface to do this kind of exploration kind of work, or create interactive documents. And the other thing is that I thought I said something about that, but maybe I didn't. I probably should. Anyways, the deal is that these, if this stuff, I've actually done this, but I haven't updated this goofy widget. But if you could read, if this thing was in a gist, or if it was in a GitHub repository, you could just pull it up, just like if it's saved on your file system. Absolutely no difference. And I've actually done that. I just need I need a checkbox or something like that, like over here, where you give new location. And a checkbox for URL, and then you would type in the URL, and it would just go and fetch it. So, like publishing stuff is pretty easy. I don't want to actually push the stuff to GIST or GitHub repos myself. I see that as outside the scope of this thing. But you could certainly have somebody save the things to the file system and then add them to a GitHub repo or a GIST, and then you could just read them in. There you are. Well, it's kind of past time, so I don't know if anybody's interested in going any further or not.
Are there any more final thoughts then? Oh yes, it's well past time. I got so carried away, so engaged with what you were saying, John, I'd lost track of time myself. If nobody else has any other final thoughts, then I'd like to thank you for presenting this. This has been great insight into the work you've been doing, and it seems like everybody else has been really enthused about what you've covered as well today. So thank you very much for that.
You're welcome.
Virtual round of applause there.
Thanks very much. Very good.
And yeah, we hope to see what you do in the future as well.
Yeah, and I hope somebody gives some comments either in Zulip stream or issues. That's how you come up with cool ideas like Chris did with this idea of plugins. I mean, that's a great idea.
Yeah, great. Thank you very much. Thank you very much, everybody, for participating and getting involved and staying around as well for this late hour as well. Okay, well, it doesn't sound like there's anything else, so let's wrap it up here for now. And again, thank you very much, everybody, for getting involved, and we'll see you next time.